some students had requested for the solution of this question. This is problem 6.43. The compound beam is fixed at A, its pin connected at B, and it's supported by a roller at C. So you have a fixed support here, you have a pin support here, you have a roller support here. Draw the shear and the moment diagram for this beam. We have to draw the shear and moment diagram for this beam. So what we do, this is the beam in front of us. In order to draw its shear and the bending moment diagram, we will isolate the beam, or we will divide the beam into sections. That is, we will divide the beam or cut the beam into sections at the points where we have what you call as a pin support. That is, say for example, this is where the pin support lies, okay? And you should always remember, as far as the pin support is concerned, the pin support offers a rotation. It does not offer any reaction. That is, the net reaction at the pin support, that is at support B, is always equal to 0, okay? But you see, so in order to solve this problem, what we do, wherever you have a pin support in a beam, you isolate the sections of the beam at that very point. So let's open up this pin support and divide the beam and see what we obtain. So once you cut the beam at the point where the pin support is, you will get two parts of the beam. So one part of the beam will essentially be like this. You will get this part BC. The part BC will be like this. This is part BC. So this is, we say this is part B, and this is part C, and here you have the pin support. Now at point B, C, you have the roller support. At point C we have the roller support. So at point C we will be having reaction upwards, what we will be calling as RC. Now look here, the total reaction at the pin is always equal to 0, okay? Once you are isolating it, at this pin you have two connections, okay? This is a connection, or this is a point, this is a joint which actually joins two links. One is link BC, another is link AB, okay? So the net reaction at point B has to be equal to 0. The reaction at point B will be because of the load on the right hand side of the point B, and the reaction at point B because of the load on the left hand side of the point B. The net has always to be equal to 0. So what we do, so we say let the reaction at point B be equal to RB. Remember, this is RB1 we write at. This is the reaction at pin support because of the load on the right hand side, and whatever be the reaction on the left hand side, whatever be the reaction at point B at the pin support due to load on the left hand side, that has to be negative of this such that the total is equal to 0, okay? So we say let at pin support the reaction is RB1, okay? This span is 3 meter, and on this span we have uniformly distributed load having intensity of 3 kilonewton per meter. Now let's draw the shear force and bending moment diagram first for this section. Then we'll take the section AB and draw shear force and bending moment diagram for it, okay?